Hello. Um, Here we are. It's a Saturday morning, and my plan right now is to go through um, the steps involved in our image enhancement and pan sharpening lab. You know, we've been struggling a little bit with it, and I don't want to say it's anybody's fault because we've had issues with OneDrive. We've had issues with image and data management, and you know what my plan is to take this video, break it up into a few steps, and those steps are going to be as follows. Number one, I'm going to show you that I've downloaded some files. I'm going to show you where they are. I have them in OneDrive, so I will be working from the cloud even though I'm at my home office. And it works. You just have to be very, very methodical. You also have to be very deliberate in how you plan and how you work with the data. The tools in ArcGIS Pro aren't too bad to work with, and well, they're great actually. They're amazing. It makes our life so much simpler. The assignment itself, I do want to take a moment to go through, and I'm going to turn off my webcam just because you don't need to see me. We'll leave the audio as is. Now, what we're looking at right now is the Image Enhancement and Pan Sharpening Lab, right? This is a submission document. The submission document requires you to prove that you understand a few things about just LandSat 8 imagery. For instance, you need to be able to, you're going to get a few marks just for inputting some file names. I want you to be able to look at the file sizes. And then the path and row and acquisition date, the reason why those are going in and the reason why they're required is because each of you need to understand what that means, right? The path and the row, that is the location of the data on the planet. Like, so LandSat 8 data, there's a grid, and we're looking at path 29 row 25, which is an XY position on our planet where there's a LandSat image. That same position, you can go forward and backward in time and look for available data to download and bring into ArcGIS Pro, and then start working with it using the composite bands tool to bring together channels 1, 2, 3, 4, 5, 6, and 7. For instance, we can use band number 8 in order to pan sharpen our true color channels, and that's another goal as well today, is to work on the pan sharpening side. So I'm just going to do the lab, and you can watch what I do, but you're required to do it on your own as well, right? So let's get to this. I have in my file explorer, right, what I'm going to do is just show you. I just highlighted 4 files. Each one of these was downloaded from Globus, and they all are of the same location but different dates. The acquisition dates are different for each of these 4 data sets. Every data set is the LandSat 8 data set, and if you look closely, each file has a name, and each file also has a size, and in the file name you can get the path and row and the date of acquisition, right? So, and then look at the file extensions themselves. This is exactly how the data is downloaded, right? And it's not until you go through and extract the data, the imagery, and the images supporting files, that you have access to it in ArcGIS Pro. ArcGIS Pro cannot work with these as they are. They are archived, compressed data sets sitting at about 900 megabytes, almost a gigabyte of data per scene or per data set, right? So last week I sent out some software that would help with extracting all of these. No problems, right? People were able to use it on their own machines at home, and there was a little bit of trouble in the lab that was causing some difficulties. But regardless, Now, I'm also working out of this folder here, and the reason why I've flipped over to it is because I've already extracted all of the data, and I've already used the composite bands tool on 3 out of 4 LandSat images that we've collected. I want to show you what happens after you've extracted the data. I'm just noticing that there's another set of data right here. That's a different sensor. We haven't talked about different sensors yet, but this one comes from the European Space Agency. It's a Sentinel-2 product, and completely different band combinations required, different resolutions as far as your spatial resolution, your radiometric resolution, your spectral resolution, and so on. So that is there. We will be working with it at a later date, but right now, all of these .tar.gz archives that were compressed, right, they've been extracted out. And what do you get when you extract the data? Well, you get a whole bunch of files. There's one here. It's a text file that just talks about, it talks about the datum, right? So that's where it's located, and it's actually projected into a UTM zone. Path and row 2925, that's in UTM zone 15, north. And you can see that this text file is pretty important for ArcGIS. You can see that there's a band list. There's 11 bands. It's LandSat 8. You can see 1, 2, 3 all the way to 11 are there. We are going to be working with bands 1 through 7 today, right? And we had in class as well. Now, what do you see here? We've got a whole bunch of information here. You don't want to modify this file at all. That's just the text file that goes along with the data. It's a supporting text file, and it's great stuff to be able to view it. And then each one of these channels can be, you can look at them in File Explorer, and that's what I'm in right now, is File Explorer. And I'm just sort of going through the channels one at a time. Here's the near infrared channel, where you can start to see the data a little bit more clearly, but it's all raw. There's no enhancements made to it, and all the channels are separate from each other, or all the bands are separate from each other, and really you can't do a lot with it right now. Band number 8 takes a little bit longer to refresh because it's a panchromatic channel. The resolution, the spatial resolution, is 4 times higher. That means you have a 15-meter pixel. You can fit 4 15-meter pixels inside of a singular 30-meter pixel. So that's pretty important to know as well. So each one of these archives were extracted, right? So you can see I've got them all there. And I've also created some other data, right? You can see here all of these TIFFs and supporting files for each data set are there. All of the channels are listed, and you can see that because at the end of each file name, right before the file extension, there's B1, B2, B3, all the way down to B11, and there's a BQA, a quality assurance channel. And that data is in its raw state, and what we did in class was we used the composite bands tool in ArcGIS Pro to create a new image, a new TIFF, and it's called B1-B7. And I've named it that so that I know that this image itself is a composite of the first 7 bands. And in ArcGIS Pro, I'm able to view the data in a multispectral color image where I'm able to flip in and out of different band combinations, and it makes a lot of sense to do it this way because now I'm able to see all of the different wavelength ranges in color. Right? Really, really great to be able to do that. I've done the first 3. I've got the June 13th image. How do I know it's the June 13th image? Well, the date is sitting right in the file. And in my file naming convention, so to speak, you can see that when I use the composite bands tool, I left the sensor, which is the first a couple of portions of the name or components of the name I left in, and then I also left in the path and row information that says that it's path 29 and row 25, and then I also left in the acquisition date, or the day that the image was captured by the LandSat 8 satellite. And then instead of having the second date, which is the date of availability, and just the band number itself, right? All I did was I just cleaned it up and went with a concise name that is for our purposes. And we talked about why that's important. You can also see some other things. A TFW was created. The TFWs, what they are they show the bounding extent of this image. Then there's some aux XML stuff. You know what that is? That's the statistics that say what the pixel values are, what those reflectance values are. And it shows, the statistics involved, what's the mean, the average, the min, the max, and all of that. And statistics are required in order to be able to enhance the imagery and apply contrast stretching to the image, and also modify the gamma channels and really dial it in and make your imagery perform and look great. In order to maximize the performance of zooming in and zooming out and panning around and all of that, you also have to create pyramids. And you can see here there's a .ovr file that was created as well. That was all done out through the composite bands tool. You got to do this when you're working with imagery. Okay, so the aux XML and the XML and the OVR and the TFW, right? Those are all the supporting files that are created when you use the composite bands tool. And this TIFF, well, that's the data. Those are the pixels. It's a pixel sandwich, right? You've got all of the different layers in there that are representing bands 1, 2, 3, 4, 5, 6, and 7, all as a single file that can be viewed in ArcGIS Pro. Now, the path and row is the same for all images in this directory, right? All of the LandSat 8 imagery anyhow. And you can see that for TIFFs, I created a June 13th TIFF, a composite, and then I also created a July 2nd, and then I also created a July 18th, but there's one more down here that is October the 6th. And why do we have these 4 different dates? Well, there's a forest fire happening in this path and row location. There's a forest fire, and it's a forest fire that happened in between Red Lake and Kenora in northwestern Ontario. And we want to look at this fire. We want to see what we can do with it. So, if you've been in class with me, you know what we're doing here, and you know what's happening. What I'm still required to do with this data is I've got to do a composite bands for the post fire, what was going on after the fire. And you know what? This image is not the best. I may even go and grab another image. But there it is. That's our post-fire image. I'm not even very happy with it, because just looking at it, there's a fair amount of cloud in it. But we still can use it, I think. We'll have to see. So I've got ArcGIS open, and I've got the project open that is right here. And I can zoom in and out, and I think right now you can see individual images. So let's look at the table of contents, the contents pane, and let's take a look at what we have in it. Right, so I added some files for you. Right now there's this NFDB, that's the National Forest or National Fires Database layer as of 2021. So you have up to 2020 fires in there. The fire that we're looking at is from 2021, so it's not going to be in this list, unfortunately. Same with this fire disturbance layer. It's not going to be in this list because it only has up to 2020. So we're looking at the Kenora 51 fire, and that's what we have. Now, this LandSat WSR2 layer I have. If I zoom all the way out, you'll see it's just like this big grid of chainmail. That's what it kind of looks like. And here's the thing. I want to try to demonstrate the path and row. Right? So what a great way to do it. I'm going to show you that if I'm looking for path 29, well, does that run north-south or does that run east-west? Well, I can just use the select by attributes and I can line it up. I can say, all right, let's go and find, and I'm doing a search on the WSR2 layer. This is the grid that shows you where all of the LandSat 8 imagery is collected on the entire planet. Pretty cool layer to play around with, and you can actually use this strategically to figure out which path and row you're looking for before you even go to download any data. Anyways, let's go and find the path. Let's just say path is equal to 29 because that is the path that we're working with. And I'm getting that from the imagery, right? The imagery that's been downloaded is path 29, row 25. So let's do a simple select by attributes, just a simple query, and find out where path and row 29 is. And there it is, right? So kind of neat to see how this works out. The projection that's being used right now is it's a world projection, WGS84, and it's a web Mercator, similar to what you'd see with Google Maps, Bing Maps, and so on. And that's just to match the base map that we have going on. But path 29 goes right through northwestern Ontario, and let's go find Kenora. There it is, Kenora. And here's Red Lake right up here. So there should be row 25 right here, but let's zoom back out and let's do another query and talk about row 25. I'll clear this off. I'm going to say select by attributes, and now I'm going to say instead of path 29, well, let's just look at where row 25 is. I've got to be searching on the right layer. There it is. Row is equal to 25, not 24, 25. I say OK. There it is, right? So row 25 should also be passing right through Kenora Red Lake. Something's not right. Did I say row 25 or row 24? I think I might have messed it up because row is equal to 25. Yeah, there it is. Right, when you zoom out, you can see that squares, each individual square represents a LandSat image. Right? And if it's path and row, well, we can do a select by attributes of that. It's a compound query, but let's just do that. Right? Path is equal to 29. And row is equal to 25. If I do that, I should only get one. There it is. So we've got Kenora and Red Lake right here. And what do you want to do? You want to see where the images actually are to prove that they are path and row 25 and 29, or 29 and 25. Yeah, we just downloaded imagery and worked with imagery in the last few weeks in class, and you can see that there's your LandSat image, and shows up fairly nicely, shows up relatively clearly. This image is path 29, row 25, but it's also the image. The acquisition date is important here as well, and what I see is that the acquisition date is showing as 2020-06-13. Right, so this imagery is like a year, or a little over a year, before the fire happened. And we have a color image, right? I just opened it up a little bit here in the contents pane. You can see that in the red position for this image, it's a color image as it's being displayed, we've got band number 4. Band number 4 is the red band. Band number 3 is truly the green band. Band number 2 is truly the blue band. And we have options because this is a 7-band image. If you just select it in the contents pane, look what happened over on the right hand side of the screen. I have the symbology pane up. The symbology pane is used for vectors and rasters, right? So this is a raster, and when you look at raster symbology, right, this is where you are able to modify how the rasters look, how they appear, the way they're being displayed. And we're using an RGB, red, green, and blue, and in the red channel, or in the red position, we are using band number 4. But we have 7 bands to choose from, right? The way the imagery might show up when you first load it into ArcGIS is it might show up like this, band 1, 2, and 3, in that order. And that's because some sensors have their bands, like the red band would be 1, and green is 2, and blue is 3, and so on. Well, if your imagery looks like this, that means you've got it backwards, or you don't have the bands aren't lined up properly, or they're not inputted properly, right? So if you want to get a true color image, you have all of these bands to work with, and you need to be able to identify which bands are which. Now, that's a good question. Which bands are which? I have another document somewhere that I'm going to pull up. Probably a good idea. Let's open this one. This is a document that I've been working with, and I'm trying to update it to ArcGIS Pro. It's currently set for ArcMap. Unfortunately, it's a little bit different working with imagery in ArcGIS Pro compared to ArcMap. It's better. But we don't use, there used to be this thing called an image analysis window, and so you could export and play around with data that way. But what I want this document for right now is I want this table. This table is awesome. I just have it as an image. I could just show it in an image editor, but look at this very closely. You've got the bands, you've got the wavelength, and you've got the spatial resolution. 3 fields or columns, whatever. And you can see that the spatial resolution is pretty much the same for every band in a LandSat 8 dataset or scene, but there are 3 different bands that are that have other sizes for their pixels, or their spatial resolution is different, right? So we've got 30 meter pixels for the first 7 bands. That's why we've made a composite multispectral image using the composite bands analysis tool in ArcGIS Pro, right? Band number 8 we will be using today in a different step. But band numbers are really important because they tell you what data is what. If you want a true color image, that means that it's got to be red to red, green to green, and blue to blue, right? So your red band in a LandSat 8 dataset or scene is band number 4. So that means band number 4 needs to be input into the red position in an RGB image. When you display or symbolize, or when you're working with the appearance of imagery in ArcGIS Pro, you've got to know that. You've got to understand that if you're displaying a color image, well, it's red, green, and blue. So a true color image is red to red, green to green, blue to blue. A false color image is, well, any of these other combinations. And we'll be making true and false color image band combinations, right? So let's do the 4, 3, 2 first, right? We've got a 4, 3, and a 2 that will make a red, green, and blue composite image. That's how all cameras work. You take a picture with, you know, your phone, and that's the way it works, is you're taking a color image in that way. So the wavelengths are important here as well, right? So the wavelengths correspond with the visible portion of the spectrum, which is about 400 to 700 nanometers ish, or 0.4 to 0.7 micrometers, however you want to talk about it. This one is in micrometers, so 0.4 to 0.7, that's your blue across to red portions of the spectrum. The near infrared, the shortwave infrared, those portions of the spectrum are also inside of our data that we exported from the composite bands analysis tool. So we're going to work with these, and we're going to enhance the images. We're going to do some contrast stretching so that we can make the images look nicer. So let's go and do that. I'll be popping back here, back and forth, and it's really, really important to understand how that works. Right now, this is a false color image because in the red position for this image, we actually have blue data. We actually have coastal data, and then we've got blue data in the green part, and we've got green data in the blue part. So the imagery is not going to look right. It kind of looks cool, but it's not very useful, right? We need to change the symbology, and you can do that using the symbology tab, or you can even just right click over here, right? What we want to do is, first, if we want a true color image, we're going to go 4, so that's a red to red, and then we're going to go 3 for the green band, because the green band is band number 3 in a LandSat 8 data set. Things are starting to change, and you can see every time you modify the band combination, it resets and re-displays, refreshes the display, and the appearance of the imagery obviously changes as well. And then we're going to go to band number 2, which is what? It's the blue, right? So that's it. You can modify the bands however you want. You can go, well, what about it? Band number 7? What happens? Well, it doesn't really make it look that different, but this is still a false color image, a 732, right? So let's stick with true color to start. And notice that red is a longer wave than blue, near infrared is a longer wave than even red, and shortwave infrared is even longer than near infrared. You can see that from this table over here. So I do want to mention that most of the band combinations that I work with, and in remote sensing, most of the band combinations that are used when viewing data are in order of long wave to short wave, right? So you'll see band combinations like 432 or 654 or 765 or 752 or 652 and so on. There aren't very many band combinations that are useful that modify and play around with the long wave to short wave order. There is one that's a 562, right? But those are really just playing around with shortwave infrared band order. Really important to understand band order, right? 432. And, you know, in this document, there's another table right here that's kind of neat. You can see a 432 is called a natural color band combination. You can get false color urban, which would help to enhance or clarify urban areas, right? Color infrared for vegetation. That's what I work with quite often, is a 543 band combination, and I'd use that same band combination across all different sensors that I work with, whether they're aerial or even drone or satellite. 543 is near infrared, red and green, right? So agricultural, look, long wave to short wave, long wave to short wave. Oh, this is shortwave infrared 1, shortwave infrared 2, and then the blue data. And you can see that all of these different band combinations are totally possible with just the first 7 bands. Okay? So that's something that's really important to understand about just working with imagery and being able to just simply and quickly enhance it. Step 1 is you use the composite bands tool to put together and create a multi-band image where you can work with all 7 bands simultaneously. Very useful to do it that way. And then there are 2 other ways to change the way your data looks. The first one is you can change the stretch type. So by default, my ArcGIS Pro uses a stretch called a percent clip. Now, if I just click on this drop-down menu, you'll see that you can go with none, you can go with a min-max, a percent clip, a standard deviation, and look at all of the symbols that are being used on the left-hand side there in this drop-down menu. They all are showing kind of like a chart or a histogram. Right? The true name of it is a histogram. And when you have none, what's happening is it's displaying the whole histogram, and that might not be your best bet. And it all relates directly with the radiometry of the image. Radiometry, what? Well, we talked about radiometric resolution, right? How many brightness values are there per pixel, right? What's your brightness range, right? 0 to 255 or 0 to 65,355. That's the difference between 8-bit and 16-bit. And when you're working with 16-bit data, you may not have all 65,000 values available. The LandSat 8 sensor is not a full 16-bit sensor. So what happens is, but it's better than an 8-bit sensor. So you're stuck with values where, if I were to go to none, it's probably going to get pretty dark looking. I've got nothing there. And that means that if I look at this, 0, black is 0, that's fine. The maximum I've got here is 33,800. That's the white pixel. I know this because the statistics have been calculated on this. 33,800 is not very bright. If you're talking in a 16-bit image, the brightest pixel can be 65,535. So what's going on here is we don't have 16 bits of data. I don't know what the bit depth is for the LandSat 8 sensor. I think it might be 11 or 12 bit, right? So that's an issue. That's why our images look dark. These histograms aren't filled, right? That's where contrast stretching comes into play. That's why we use contrast stretching, because if we use a percent clip, or even a min-max, what it does is it finds the minimum and the maximum values and it applies them. But even here you can see that the image is relatively dark, and there's actually a little bit of atmospheric scattering happening. It's pretty blue looking. I'm not a fan. We need more contrast. We need more brightness. We need to see more difference between Earth's surface features that are being viewed here, and we can use contrast stretching to do that. And then we can further enhance the imagery by working with the gamma across the red, green, and blue bands that are being displayed, regardless of what band is the source, whether it's true color or false color. So let's look at percent clip. Let's see what it looks like, and you wait for it. You can see that when you use a percent clip, it clips off the brightness, it clips off the maximum and the minimum by a certain percentile. And what's happening here is I'm saying, get rid of the top 0.25%. And if I were to, I could really modify the contrast here if I wanted. I could say clip off the top 5%. As soon as I do that, look at how bright the image gets. Now, is that useful? Well, I don't know. Let's look at something that's really bright. I've zoomed in too far here, it's pixelated and so on, but look at this stuff here. We've got some roads, we've got maybe a cut block. It's over exposed. Don't like that. We've clipped off too much. Right, so if we go to like 1, what does that do? Oh, we really are able to see more detail. Right, so you don't want to go too bright. Obviously, you don't want to be too dark, so you've got to kind of find that sweet spot. I prefer the percent clip. It's one that I've used across many different platforms. You know, there are other pieces of software that use the percent clip as well, and I prefer it. As far as a clip at 1%, I usually don't like to. I like to see as many gray level values in the mix as possible, so I usually don't clip more than 1%. And what happens if we boost the percent of clip off of this histogram at the bottom? If I go to like 10, what's going on there is everything in the shadows is going to be clipped out and it's just turned to black. Don't like that at all. It does help to increase the contrast significantly, but I like to see as much of the histogram as possible. But the minimum maximum one, that contrast stretch just doesn't do it. Like if you go min max, right, you can see everything, but it's just there's not enough there. We need to clip some of that off, right? So I typically run, I don't know, 0.5% on each side, and it really helps to bring out the values. Now, as far as color balancing goes, you can do that with the gamma. Right? So the gamma, right? The gamma is a way of modifying the bands. The only problem with it is I usually keep my gamma balanced across all channels. That's really important if you're wanting to really get a good look at how the reflectance values are coming at you, right? The raw data, right? The computer is able to work with that, but as a human, I want to be able to see things and I want it to look good. This is way too green, in my opinion, right? What happens if I turn the gamma down on the green? Well, which one is the green? There's 3 numbers for gamma. This one here represents red, and I could turn it way down. What do I get? Well, I get less red, and oh, I don't like it, right? Some things are enhanced in such a way where, you know, they should have more red. In a true color image, right? 1, 1, and 1 corresponds with how much red, how much green, and how much blue. I consider gamma to be kind of like where, you know, if you have like a translucent piece of paper and you put a flashlight behind it, right? How close is that flashlight going? How much is it helping the pixels to kind of glow, so to speak? Right, so what happens if I dial things back? In a true color image, I usually dial my blue back a little bit, and then I also dial my green back a little bit as well. And what it does is it helps me personally, just the way I like my imagery to look. This is it. It helps to bring out some of the non-forested areas. It helps to make the forest look not too green, not too blue, but also not too red. It's color balance, right? So we've looked at how you can modify the band combination. We've also looked at how you can apply different contrast stretches, and also how you can modify the gamma. And this gamma that we've played around with here, it's not a permanent thing. You're not writing this to the image. It's just how it's the appearance of how it's being displayed. Okay? And in the lab, you're required to work with the gamma, the contrast stretches, and even the band combinations to enhance the images in different ways. That's what this lab's all about. Okay? So let's go over and look at what we're required to do in the lab. Right? The first question refers to just understanding the file names and the file sizes, right? So we've got, I downloaded 4 different LandSat scenes, and here there are 3, right? File names, where are we going to even get the file names? Well, remember, we've been working with data. I've got them right here. We've got one called this is how it comes straight from the sensor, so I have no problems with you using this file name, and that's exactly how you get the data when it's received from the USGS, whether it's through Earth Explorer, Glovis, whatever, right? I've got one there. I'm going to bring it into my Word document, and it's 897 megabytes. That's totally fine by me. There it is. It's 897 megabytes, approximately. I'm fine with that. The path, well, I don't need to go back to my File Explorer to find the path. The path is sitting right in the file name, right here. Right, so we've got path 29, row 25. The acquisition date is sitting right in the file name. We've got 2020 06 13. That's what I'm looking for. Each of you are to fill this out. Go through the process of doing it. It'll really help you. And you might think that it's a waste of your time, but it really isn't, because working with LandSat 8 data, you have to know the path, the row, and the acquisition date in order to be able to keep yourself organized, right? That's just it. So now next it says the first 7 bands of each LandSat scene were added to ArcGIS Pro. What geoprocessing tool was used to create color composites? Describe how this tool works when combining more than 3 bands together. So I'm not going to answer this in this video by typing it out. I'm going to do a demonstration, right? So I will be working with that. Before I do the demonstration of the composite bands tool, I'm going to be looking at question number 3, where it says true color composites were created together in class using the pre-fire LandSat 8 scene. That's this one right here. June 13th of 2020 is like a year before the Kenora 51 fire. It says, please use side-by-side screenshots displaying the entire footprint and show a true color composite being displayed using 2 different contrast stretching methods. Please label the screenshots describing the enhancements that were used. You get 2 marks for that. So let's go and do that. Let's grab this one right here. June 13th is the pre-fire image. And if I zoom out, you can see that, you know, we're working with it, and we've already dealt with the path and row stuff, so I'm going to clear the selection. I'm actually going to turn off this topographic map. I'm going to turn off this as well, and just focus directly on the image itself. I'm going to try to make this so that it can be viewed on screen without a lot of problems. And you're not required to do this, but I'm going to modify the coordinate system of my map view to match the LandSat data, right? My map view currently is in Web Mercator, which is a world projected coordinate system, and the data was delivered or downloaded, also projected, but it's using UTM. So I'm going to use the same. This will just help to make the data look the best, right? You don't want to be messing with alternate or differing coordinate systems. Looking at this data from, you know, a scale of, I'm at about 1 to 1 million right now, 1 to 1 million, I could see the communities of Kenora and Red Lake. I'm pretty sure this is Red Lake right over here. If I zoom to it, you can see, I think that's Red Lake. I can turn this topographic map back on and check. Oh, no, that's Ear Falls. Where's Red Lake? I think I have Red Lake in the image as well. Yeah, there's Red Lake up there. This is Red Lake. So we've got Red Lake, and we've got Ear Falls, and we also have Kenora. So this image, you know, there's 3 communities in this area. The Kenora 51 fire was large, it was dangerous, and we're going to find out how close it got to Red Lake and so on. So I don't need my topo map on. What I want to do is just work with enhancing this image. I've already enhanced it the way I like it. It's using a % clip, and I've modified the gamma, right? So again, what happened to my symbology pane? Why am I not getting anything in the symbology pane? Well, you need to actually select the layer in the contents pane that you want to symbolize, right? So I'm looking at the symbology here now for this image in the symbology pane because I have it selected in the contents pane. That's how that works. If I want to change the symbology of a vector, like this NFDB layer, the fires database layer, see how, you know, it's set up to symbolize that way. I have it turned off. I don't want to work with that one. I want to work with this one. And when this one is, this particular layer, the June 13th layer, the image is selected, you can see that there's an appearance tab up at the top, and you can modify stretch types up here as well. It's the same. It's not like it's any different. And, you know, you can play around with resampling types, and you could modify the brightness and the contrast, and this looks like it's the gamma, right? But these do all three at the same time. And you've got different rotations. North is up, that's what we have. What is up is up? Doesn't really do anything, right? But you can play around with rotating pixels there as well. Now there's also swiping. Swiping is kind of neat. Swipe up and down. Why would that be important? Well, we're going to be playing around with that later, but turning swiping on and off is kind of neat. You can make them transparent. You can do all this stuff in the appearance, right? Tap. The ribbon makes things so much simpler, this ribbon interface. ArcGIS Pro is awesome. I've made friends with ArcGIS Pro. You know, this is my first year teaching with it, and I absolutely love it because everything is at your fingertips. You know, it's not like things are hiding inside of, you know, properties, windows, and you got to dig. Everything's just right out in front of you. And it should help to build an understanding of, you know, just enhancements for images and different symbologies for vector layers and so on. Let's take a screenshot of this right here. Maybe I'll go to a scale of 1 to 1,000,000. Can I get the whole thing? I can. But all I did was I just minimized the ribbon. So at a scale of 1 to 1,000,000, I'm able to get a decent screenshot here. And all I'm going to do is I can take notes of the symbology, the primary symbology of this raster, this June 13th. And for me, taking a screenshot, you know, I'm going to grab the whole screen. And in the Word document, where I'm required to put in the screenshot, all I'm doing is just pasting this in. And I'm just going to crop it down so that I can see the whole image. There's one more thing I am going to note. And that is, you know, the image is rotated, but it's not really rotated. What's going on is it's in UTM 15. We'll talk about that. The Alex off. Now I have to go back and grab another screenshot with a different enhancement. Now you're not required to use a completely different methodology, but this is how I would like to see each of you displaying your imagery. Something nice and crisp and clear where you can see all of the bands nicely, and you're going to see, we'll get into the false color stuff soon. But I also want you to just experiment with some different ones. Like standard deviation is another one that I enjoy using. When I just go to the defaults for standard deviation, this is what happens. And interestingly, my red is too high now. So let's bring my green up and my blue up in the gamma. But notice with standard deviation, what's happening is there we go. With standard deviation, what's happening is everything is grayed out. It's not the best looking. Is there a way we can take this and make it a little bit better? Well, what is standard deviation? Standard deviation works from the center outwards, right? What's the mean? The mean pixel value. What is the mean pixel value for each channel? And then if you go one standard deviation out from the mean, what you're doing is essentially clipping the mins and maxes, very similar to a percent clip. And you do that with all three channels. So if I want to increase the amount of contrast here, I could just go to one standard deviation away from the mean. But look at what it's doing. Everything is just super bright, right? If I go to 3 deviations away, everything darkens up. If I go to 4, same thing. But the amount of contrast that I'm seeing in the imagery is not really that great, right? If I zoom in, it's a little bit difficult to see the colors, the vegetation, and so on, right? So what can be done? Well, maybe if you go back over to the Appearance tab and you boost up the contrast, what happens? In a standard deviation. See that? Now we're looking at this and we're saying, oh wow, that's not too bad, right? So again, the thing with standard deviation is, well, does it make your imagery look even any different than others? Well, sure it does. I've just boosted the contrast big time with the available levels, and my lakes don't look as blue. The ground, the non-vegetated areas look very brown. I don't mind that at all. You know, I could turn some of this down, or maybe I could bring the green up a little bit, right? You can modify the gamma however you want, but what this is doing is it's showing almost the whole histogram. I can even go up to like 8 standard deviations. That's, you know, that's the entire histogram pretty much, and it's just too dark. If I go to 1 standard deviation, well, now I'm just like way out there. That's because of the amount of contrast I've applied to it, right? 5 too much, 4 too dark, 4 is a little bit better, 3 too hazy looking, right? So 3.5, can you do 0.5s? You sure can, right? 4 standard deviations, looks pretty nice. That's deviations off the mean. I'm not going to get into a statistics class right now, but I'm liking this. Let's set the scale at 1 million, and let's take a screenshot and then place it right beside the other enhancement that was made in the Word document. The other enhancement was, if you remember, a percent clip, right? Where we had to modify the gamma. No, with standard deviation, instead of modifying the gamma, we had to apply contrast directly and equally across all 3 bands. So let's grab a screenshot of this, throw it in the Word document, and get ready to move on to the next portion. I'm going to put it right beside. Same thing, I'm going to crop it down so that they look to be exactly the same scale. So we don't want to be, you know, zooming into one more than the other. We want to look at this and apply, you know, kind of like an apples to apples comparison, and be able to get an idea as to what different contrast stretches do, right? So on the left we've got a percent clip, on the right we've got a standard deviation, and they're both you can use both of them, and you can see what's going on with the percent clip and the standard deviations, and you can wonder, okay, well, which one is the best? It's, again, it's totally up to you as the user of the software to decide what you want to do, right? I like standard deviation, but I also like percent clip. They're both great enhancements, contrast stretches. So at left, the enhancement is percent clip, type, with the gamma tuned set to 1.0, 0.8, and 0.9. That right. Standard deviations, contrast, stretch being used is standard deviations and contrast added from the ribbon. Set, and I used 4 standard deviations and contrast added from the ribbon interface to modify the appearance. Okay, so we can take this and obviously dress it up a little bit, bring it down, take the bold off, take that off, maybe use centering. Alright, so this is a complete answer right here to question number 3. Right, that's full marks because what you've done is you've done the contrast stretching, you've used 2 different ones, and what you've proven is that you can do it. You can change the enhancements, right? And I don't care, you don't need to use the same ones that I've used, right? Play around with histogram equalization, play around with the Esri contrast stretches. Try them out, see what they look like. And it doesn't, you're not going to be graded based on, you know, whether or not the enhancements are really fancy looking. You're being graded here on whether or not you've modified the imagery and enhanced it in a way that is different from just the raw images that are loaded up, right? So there's a question being answered right there. Now, a few other things to do, right? So false color composites. We did those in class as well. We did the following band combination. We did a 543, we did a 752, a 765. We used a 765 because with regards to forest fires, the 765 is excellent for seeing through ash and smoke plumes, right? And we will see that coming up. So again, you know what, I'm just going to keep going here, and I know that, you know, it's starting to get a little bit long as far as the video length, but it's important for us to keep pushing forward and keep going. We want to eventually also look at these true color images, and we want to export them out so that they can be pan sharpened. And in fact, you know what, that's what I'm going to do next. No, it's not. Sorry. I'm just going to go right to the false color stuff. I'm just trying to think of, you know, efficiency of time and the video and so on. But this video is, it's really important that we understand how to apply contrast stretches to not just true color imagery, but also false color imagery. We haven't even really seen any false color anything yet. In the Word document, that first one in number 4 is a 5-4-3 combination. Well, what happens with this 5-4-3 combination? How do you even modify the bands to be 5, 4, and 3? You can do it in the contents pane, or you can do it in the primary symbology of the symbology pane for this particular layer, as long as it's selected in the contents pane, right? You see, I have it selected right now, and you're seeing what contrast stretch was applied to this June 13th image. I'm going to just switch up my bands. I'm going to go 5, then I'm going to go 4, and then I'm going to go 3. Now this contrast stretch is not very contrasty at all, and I'm going to flip this over to, let's see what min-max does. Something's not right here. Let's go and look in the ribbon and see what's going on. There still is contrast being applied. Let's take this right down to 0. There we go. This is how I would normally expect to see a false color image, right? This is false color, near infrared red and green, which is for vegetative analysis, and I'm looking and I can kind of see where the vegetation is. Anything that's really bright red is vegetated because of the amount of reflectance that you get off of vegetation in the near infrared band. The stretch type of min-max, not really liking it. What do I have for his percent clip? Percent clip does a great job differentiating between vegetated and non-vegetated areas. What I'm also expecting to do is see the difference between conifer and deciduous. Now that near infrared band, it's great, right? It's awesome, but what I'd like to do is dial it back a little bit. If I go to like 0.7, you can see that it brings the amount of reflectance off the red channel down by quite a bit, and that helps. And you know what? I'm going to reduce the amount of clip that I have on my lower end. That'll help to brighten it up a little bit, and kind of, I want to see right into the shadows. And same thing here. I'm going to bring my percent clips to really, I want to see the entire histogram if possible, but not the min-max. Now let's bring the blue down a wee bit as well. Let's go to like 0.9 for the gamma. Now we're getting it. And let's actually bump the green up and see what that does. I'm liking this a little bit better. And what I'm staring at is actually this area right down here. Right? We've got some cropland, right? Some agricultural stuff going on. But then right beside it, you know, we've got areas that are either deciduous or conifer lead. And what I mean by that is coniferous trees are going to show up, especially in northwestern Ontario, as being, you know, in the blues, purples, maroons, browns, and colder colors. They're not going to be as hot, so to speak. And anything that's super hot is either going to be grass or hardwood, like hardwood trees with leaves, broad leaves, right? Anything that's on the hot side is hardwood. And when you work with your data and you enhance it properly, you can really get a nice clean look to it and see the differences between hardwoods and deciduous. It's really important to be able to do that, right? Because that allows me to look in these areas and say, this is a conifer swamp right here. It's actually not even fully treed. This is, you've got about maybe 30 to 40% crown closure in there. Whereas you look in some of these other areas, and you know, this area right here is heavily treed. Those purple pixels, to me, just interpreting this, tell me that I'm looking at black spruce, right? And then you've got an area right here that's more on the like maroon kind of, and I can tell it's upland. You're looking at jack pine with a little bit of spruce in it there. And yeah, I'm working on 30-meter pixels here. How are you even able to do that? Well, it just comes with experience. You can see things like rock, you can see things like swamp and non-forested, open muskegs, treed muskegs, all the different polytypes that the Ministry of Natural Resources and Forestry here in Ontario are looking for. And you know, the image is quite nice, it's looking good. I can see areas that are a little brighter. That means that you've got less vegetation, more rock, and in fact this area is not really very heavily vegetated at all. As you get closer to some of the larger centers, you'll see a greater number of trees because you're going to have fewer cut blocks, you're going to have more protection from forest fires in populated regions or populated areas, right? So kind of neat to look at this area in this band combination. It's just one of a few. You get up into this area and you're like, well, what is even happening here? Why is it that this has almost no trees in it? It's not a cut block. That to me looks like a previous fire scar. In fact, so does this up here, and so does this up here. They're all, and then you have some that are coming back, and lots of rock in this area. Wow. Wow. Anyways, right? We're looking at a false color image. I'm liking it. It looks pretty good. Maybe I will dial up my blue a little bit more, see what that does, right? It starts to bring in that's actually not the blue channel though, remember, that's green data, right? So that's going to increase the amount of reflectance coming off the vegetation, so I'll keep it at 0.9. I might even dial up my red a little bit more, 1.2. And I say red because the red data is in the green position. What does that do? Does that allow me to see a greater difference between conifer and deciduous? It sure does. Look at the cool areas in here. Look at what we're seeing. There's some really interesting stuff happening, right? When you zoom in. How close can you zoom in? Well, as close as you want, but I mean, how useful is this? I could measure these pixels. This water pixel right here is 30 meters by 30 meters, right? Ish. Exactly, in fact. When I zoom out, how far do I have to zoom out before the image makes sense, before the image becomes not pixelated anymore? And it turns out that with LandSat 8 imagery, it's right about 100,000. A 30-meter pixel is only useful outside of 1 to 100,000 scale, right? You're not going to zoom into 50,000, and yeah, you can recognize features, but the image degrades, right? So a 30-meter pixel is meant to be viewed right around 100,000. That's as close as I've ever wanted to get into a LandSat image, and you can see a lot of things can be mappable. It's great. It's a beautiful looking image. As that resolution increases, the spatial resolution I'm talking, as that resolution gets better, I should say, you can zoom in that much more. And that's the second half of this lab. We're going to be pan sharpening down to a 15-meter pixel, and we should be able to zoom in a little bit more to see a little bit more detail. And that's what I'm looking forward to doing. Anyways, let's look at the Word document and see what's required of us. So I've got a 5-4-3 band combination. We want to see the full image scene, right? This is a full image scene right here. We see the whole thing, right? So you're going to be at a resolution there, or sorry, a scale of 1 to 1,000,000. And then I want to see an interesting area zoomed in to 1-to-1 raster resolution. I want to see these side by side. You get 1 mark for each. So let's take care of that. And this is also going to give me an opportunity to show you that when you're working in ArcGIS Pro, you can just right-click on stuff to help you. Right? If I right-click on it and I say zoom to layer, and what I'm right-clicking on is the image that I'm working with right now. If I say zoom to layer, it brings me out to, well, a scale of just over 1,000,000, right? If I get rid of my ribbon, and then I zoom out to the layer, it zooms me in a little bit more, and I'm almost at 1 to 1,000,000. So let's just type in the number 1,000,000. That gets me right in. I'm able to capture the entire scene on my screen at a scale of 1 to 1,000,000. That's what I want you to use to give me the full scene. I've been using this, and I'm going to apply the same scale across the board. So Alt Print Screen for me. It could be Function Alt Print Screen for you, or even use, like some kind of a clip tool. There's a few different ones. So let's put this in right here and crop it down. I just right-clicked to crop this. It's going to allow me to put it at the left side and then go and grab another screenshot at full resolution. I was just talking about full resolution as being at a scale of 1 to 100,000, right? So there's got to be some area in this image that's cool or interesting at a scale of 1 to 100,000, and that's what I want to see you do, is also go and explore the image, right? All the pyramids are built and the thing looks awesome. We've played around with different band combinations, this one being a 5-4-3. Why not go and start looking for weird stuff? Like, what is that? What is that? to me it looks like some forest operations, right? What are we looking at here? This looks like it's an old fire scar with a whole bunch of swamps in between, right? It goes rock, wet, dry, wet, dry, wet, dry, rock to swamp, right? Same thing going on over here. And where do you zoom into? Well, 100,000 will give you the full resolution of the imagery. This is an interesting area. Like, look at all this weird geology happening. So I'm also going to turn off my contents pane, and I'm also going to turn off my symbology pane, close my catalog pane, close the pop-ups, and look what I have now. Look at all the screen real estate I've gained. And at a scale of 1 to 100,000, I can see some pretty interesting things. Lots of jack pine in there. There's something weird going on with this lake. There's even some like twisty geology things happening here that are kind of neat. So what do I want to do? Do I want to maybe look for one of the communities? Ear Falls, Rainy River, and so on. Right? What am I looking for? This is Kenora. I know somebody that lives in Kenora. My Auntie Jeanette. Hi, Auntie Jeanette. And we've got some weird swamps happening over here. That's kind of neat. I don't want to zoom in beyond the resolution of this imagery. And what I mean by that is there's a 1-to-1 resolution for this LandSat image, and that's at about a scale of 1 to 100,000. Don't go in beyond that because it's just going to degrade the image, right? You want to look at things as they are and find something that looks interesting. There's so many things to choose from, and choose something different each time. I'm just, I'm stuck right here. This is where I'm going to do it. I'm going to grab this. Maybe I'll even maximize out this window. Check this out. Now I've got even more screen real estate, and I can grab a screenshot of that. Bring it into my Word document so that I can show off all this cool stuff, right? I just have to crop it down so that it'll fit beside the other. Crop the top, and maybe bring this over here. This in a little bit more. Notice I'm cropping it now, but everything in this image is still going to be at this same scale, 1 to 100,000. Just trying to get them to be beside each other. There we go. Can I get a little bit more? Now they're beside each other. There it be. So, I'm not going to spend a lot of time talking about, formatting your Word document and all of that, right? But that's important as well. Do I want a description? Nope. Don't need a description. What I want to see is that when you do these screenshots, they're beside each other and consistent, right? So 2 different scales, same band combination, and so on. Let's go and do the 752 together, and then I'm going to move on. 752, full image scene in an interesting area. Well, we're going to start to get the hang of this now, right? So let me just drag my window back into the middle. Let's grab our contents pane again, because we need it. Let's grab our symbology pane. Well, I guess I can just right click on symbology to get it back there. That's all we really need to work with. So let's zoom out to the full layer again, and in the symbology pane now we need to modify the band combination. 7, 5, and 2 gives us an interesting look. But what's happening here? We've got a % clip. Is that the correct Is that what you want for your band combination? Yes. Is that what you want for your contrast stretching? Maybe, maybe not. I don't know. Can you make it look a little bit better? Well, what's happening is our percent clip looks fine, but our gamma is still set the same for when we were working with the 543. So let's just reset it. I just double click to get in there and go 1, double click to get a 1, and double click to get a 1. This is how a 752 looks. I would say the green is a little heavy, so I'm going to bring the green down. I'd say the red is a little bit weak. Let's bring the red up. And the blue, I'm going to leave by itself. Right, so notice what we see now is different Earth surface features are showing in different ways. Look at what happened to these areas that were all burned. Look at that. Isn't that cool? All of the little swamp areas in this region are still showing as green. They're vegetated, right? Anything that's vegetated is going to show as green because our near-infrared channel is currently being displayed in the green position. Remember, the near-infrared channel is band number 5. And we're displaying band number 5 as green in this color composite. So that allows us to kind of get an understanding of what we're looking at. Anything that's very not green is not vegetated, right? So the lakes and the rocky areas and so on are going to be not vegetated. We know we've got a little area down here that is, there's some agricultural stuff happening. And in June, in this area, we're seeing that some areas of cropland are vibrating bright green, but others are showing as very pink. That means it's like open ground. And it being early June in northwestern Ontario, it makes sense to me because, well, I'm not going to have a lot of cropland doing well yet. Look at how things have changed with regards to the wet land areas and all of these really sopping wet organic fields. Look at the cool patterns that you're getting. I just love looking at LandSat imagery. It's so cool to look at. I just absolutely love it. So do I need to further enhance this 752? I could mess around with it a little bit more. Do I want to dial my green back a little bit more? It's so green that do we need all of it to be that green? See how by bringing the green down a little bit, it changes how. I think I need to bring my red down a little bit as well. Maybe not that much. Let's go to, come on. I like that. Maybe I can dial my blue back a wee bit. Let's see what that does. So I'm just modifying it, and you don't want your reflectance values to be oversaturated or overexposed, so to speak, right? You want the water to look dark, and you want all of the different features to show and you want them to show the maximum difference in color between different Earth surface features, right? So I've got, anything that's not vegetated is glowing like a pinky kind of red color right now, or purple, and the conifer versus deciduous areas are showing as being dark green versus bright green, right? It's kind of a neat way to look. And I absolutely love the 752 band combination. Look at the color of the water. Like, it's just, water is showing up as a really rich blue color. I think this is Ear Falls, right? And it's showing as like a purple color for, and that's, your pavement and your sand and gravel or anything that's not, like fully not vegetated is going to be as far away from green as possible. and that's kind of how that looks. Kind of neat, right? So let's get the full scene. Zoom out to the full layer. Let's see what we can get here. Can we go to 1 to 1 million? Sure can. And this is what a 752 looks like. So let's get a screenshot of it, put it in the Word document. There's a pattern of what we're required to do. This Word document may be useful as a reference for you for future. You know, if you're working with LandSat 8 imagery, this document is kind of like, you could be using it for your notes as well, where it's just like, you know, look at all the different band combinations and look at the difference between a 543 and a 752. Is it useful? Absolutely. Here's a true color one, right? And you can see how this is working out, I hope. Now let's look at an interesting area at a 1 to 1 resolution. So let's grab this. I'm going to maximize it so that I can see as much as possible. I really want to show how this area right here is reflecting, because it's an area that has been burned recently, I'm suspecting, because it's fully non-vegetated and it doesn't make sense that there would just be no trees there at all, right? So let's get this to 100,000 for the scale. This is my second screenshot. I'll print screen for me, get it into the Word document, and move on to the next step, right? So I got to crop it down, and let's crop it down so I still want to see that burn area. That should be getting me close. Come on. I want them to be right beside each other. Make sure you crop and that you're not reshaping these images. I don't want to see any distortion. There we go. Yeah, so I'm liking that. We'd like to see them both on one page. There we go. That's beauty. I know it's a little bit tricky and a lot of fiddling around. But look at what we're doing here, right? We're looking at different band combinations. We're looking at different scales. We're looking at different contrast stretches and enhancements and levels for gamma across the different wavelengths that we have entered in or loaded into the imagery that we've used the composite bands to create, right? Anyways, 752 is done. So I'm not going to steal the show, right? This is an experiential thing, and I want you to do the same process. We did a 543 and a 752. Now continue onwards, right? Do a 765, a 654, and a 562, right? I can very, very quickly show you what those look like, but you know, it's really something where I'd like you to be discovering it, right? So, you know, if I were to just, you know, flip these around, 7, 6, and 5 should be very blue, and in that case, you know, I'd be probably dialing up my green and dialing up my red and dialing back my blue to show this stuff, right? And it's, again, a way of looking at things. So there's a 765, that's pretty cool looking. 1 to 100,000. Things just have a way of showing up in different ways. And look at how much the water has changed in a 765. All of a sudden, anything that's wet is going to show up as really dark, right? And that makes it more mappable. That's a 765. There are some other weird ones, a 562 or a 563. Show things in strange ways, right? And what I would do here is I'd be dialing my red right back, and I'd probably bring my blue back up, sort of look at things, and everything that's really blue is showing up as relatively bright, and it's kind of neat, right? So here's another band combination that's used, and again, it's a matter of keeping track of which band you're looking at, keeping track of the enhancements that are being done, especially the gamma, because the gamma always has to be fine-tuned again after you switch your band combination out. That's a really important note for everybody. And if you don't feel comfortable playing around with gamma at all, you can just leave it at 1. I do suggest that you do not push your gamma beyond 1 very often unless you feel you have to. Okay? Just because you'll get into situations where your images are going to start to degrade, right? So anyhow, LandSat imagery, you can modify it in so many different ways. And the next video, what we're going to do is we're going to start looking at time analysis, right? Because we're just looking at, currently we're just looking at the image that's like from almost a year before, or even a little more than a year before a fire happened. And in this area there is a fire. And we've got an image here that shows the fire in action. It's like an action shot. And if you look, the date is July the 2nd. And that is a fire, that's not a cloud. So that's going to be what's happening in the next video. We're going to start working with multi-temporal images in the same way that we would be working with, in the same way that we worked with the pre-fire image. We've got pre-fire imagery, we've got during the fire imagery, and we have post-fire imagery. And we want to look at all of them for the same path and row. Okay? And that's just it. So, you know, for me, %clip, I'm looking at this and I'm saying, well, those values that were inputted may not work for this image, right? 0.5 and 0.5 I had used for the true color stuff, and look at what's going on. Oh wow, cool. Look at the smoke plumes and the ash plumes coming off this fire. The imagery is a little bit dark, but the reason why it's dark looking is because of all of this smoke and ash that are in the image. All of those white pixels are kind of washing out everything else, right? Because of the histograms, right? The blue channel is actually much, much brighter. But how are we going to make this work? What are we going to do to make these values look better? Well, we can play around with the gamma. We can say, let's go to 1.2 on the red and the green. That helps out a little bit. Maybe too much green. But the blue, bring it up as well. I guess it's not too bad. But we're still stuck with not being able to see through that cloud. The next video, we're going to solve that. Alright? So we've got that, and we've got another data set right here. I've got 3 data sets. I've got the pre-fire, I've got the during the fire, I've got 2 of them. There's this one as well. It's not the best. We'll work with what we've got. And then there is another one that's after the fire, and I haven't even processed it yet. I haven't even run it through that composite bands tool. So maybe that's how I'll start the next video, is we'll work with the October 6th image. And we'll run it through the composite bands. We'll do a little bit of image enhancements on it. We'll look at some of the questions in the Word document, and we'll start looking at how different band combinations can be useful when you have an active forest fire. And let's think about how that all works. Alright, so I'm going to just say thank you and bye. Maybe I'll turn on my camera again and say thanks a lot. I know that these videos are long. I hope they're useful. Yeah, see you on the next one.